Hello and welcome to this video in the R Analytics course. In this video, we will look at matrices and arrays, the data structures we had talked about in an earlier video. Matrix is that data structure where data can be stored in two dimensions. Suppose we have a data set of quarter 1, quarter 2, quarter 3, and quarter 4 for the north, south, east, and west regions. We have the values for the corresponding region and quarter in all the cells. Thus, every value represents a column and a row. Such cross-table reports are known as matrices. Matrix data basically gives us the value corresponding to both a row variable and a column variable. Let us now see how we create and handle matrices in R. We create a vector named A with sequential data from 1 to 12 in it. Then we take B and put it equal to matrix. The first argument is the data input that we have to give for the matrix for which we write A. Second argument is that how many columns and rows should be there in the matrix. And lastly, we have to tell R that we want these values stored in A to be inputted in B row-wise or column-wise. These are the four arguments that one has to mention to create a matrix. In case we do not mention any other argument and press enter now, then B will be represented as a column vector. This means that by default R arranges values in a matrix column-wise. In the matrix here, there are 12 rows and 1 column. This is known as a 12 by 1 matrix. We now see that how we can define the number of rows and columns we want in a matrix. We write B is equal to matrix A, number of columns is put as 3. Now if we press enter, we can see that the matrix has 3 columns and 4 rows. We must remember that the product of number of rows and columns will always be equal to the number of elements in the vector, which is A here. We now extend this by giving the number of rows also in the code. We can see we get the same result as before. One must notice that values have been entered into the matrix column-wise, which means that 1, 2, 3 and 4 were entered into column 1, and only once all the rows got exhausted did we shift to column 2 and then to column 3. By default, the values are entered column-wise only. To make it pass through rows, we write by row equal to true. Now when we execute B, we can see that the values are being passed by rows and not columns. What will happen if the number of elements in a vector are less than the product of number of rows and number of columns? Let us create a matrix D and input the values 2, 3, 5 and 7 in it. We put n col, that is number of columns, equal to 4 and n row, which is number of rows, equal to 4. We can see we have only 4 values in the data to be entered, but the product of rows and columns is 16. Now when we press enter, we can see that the same values have been repeated in all the 4 columns. This is because we had just 4 values, but the number of elements we wanted was 16. We can see here also that the values have been inserted column-wise, starting with column 1, where all the values were entered, and then we moved to the subsequent columns. Therefore, if the number of values is lesser than the product of rows and columns, then the values start getting repeated. This is also known as recycling. Let us now look at some functions in matrix. Two functions we look at are rbind and cbind. One is row bind and the other is column bind. These functions are used to add rows and columns to an existing matrix. For example, we have a matrix B. Now we want to add another row in this. We write rbind. In the first argument we mention the matrix, which is B. Then we tell R what values we want to enter in the new row that we want to add. For that, we write combination of 10, 20 and 30. Now when we press enter, we can see that a new row with these values have been added to the matrix. One interesting thing to notice here is that if we execute B now, do we get all the 5 rows or we get only those 4 rows that we defined earlier? As we see, we get only 4 rows in B. This is because we added a row through rbind, but we did not store the new matrix in any variable. To ensure that B would have changed as matrix to 5 rows, we should have written B is equal to rbind. Now when we check for B, we get all the 5 rows and 3 columns as expected. Similarly now, we use cbind to add another column to this matrix. We write cbind. In brackets we write B, following which we enter the values for that column. We press enter now. As we can see that there is an error here. It says that the number of rows of result is not a multiple of vector length. We can see that the new column that we wanted to add should have had 5 values, one each for every row. However, we just have 4 values in our code. This is why this error popped up. What if we would have inputted more than 5 values? Now if we press enter, we do get the matrix B generated but with a warning message. This again tells us that the number of values is not the same as the number of rows. Let us look at the output closely. 2 new columns 4 and 5 have been added. Column 4 has the values 12, 16, 22, 24 and 12. This is happening because the number of values was lesser than the number of rows earlier. Hence, R repeated the first value of 12 in the 5th row. In the 5th column, we get the first 5 values and the 6th value of 40 gets dropped. Thus, if the values are lesser, then they get repeated, and if the values are more, then the extra ones get dropped. Now we will learn how to give headers in a matrix. For that we use functions called row names and column names. We write call names of B and put it equal to zone 1, zone 2, zone 3, zone 4 and zone 5. Now when we execute B, we can see that every column has a header that we had defined. Similarly for rows, we write row names of B is equal to Jan, Feb, March, April and May. We can see that B now has both column and row headers, and it looks very similar to the table we saw earlier in the Excel sheet. We will now see how to extract or access the values of a matrix. For that, we write the name of the matrix, which is B in our case. Since this is a 2-dimensional data, we need to mention both the row and the column for the value we want to access. Thus, we write B in square brackets and we write 2, 4. 2 stands for the row number and 4 for column, which means we want to access the value for Feb month in zone 4, which is 16. We can check it for row 4 and column 2, which gives us the output as 11. This is how the values of a matrix are accessed. It is very similar to the function index in MS Excel. If we want to access the entire row or column, then we will again use the square brackets. We write b is equal to comma and then say we write 2. We can see the result we get. It gives us all the values for column number 2, which is zone 2. Therefore, if we do not write anything before the comma, it means we want all the values for the rows, and similarly, if it is a blank after the comma, then all the values of the column are extracted. The fact that the output is given in the form of a vector, that is why it is appearing to us as a row. To make this into a column, we can define it as a data frame. For that, we can write d is equal to data.frame, and in square brackets we write b followed by comma and then 2. Now when we press enter, we get the column as expected. By default, the values get generated in vector form. In case we want it in the column format, then we can create a data frame. Similarly, if we want all the values for the month April, we write b and then 4 and comma in square brackets. We can see we get the desired output. This is how we create and handle matrix in R. We can also find the sums and means of rows and columns if required. For example, we write row sums and then b. We can see we get the sum total of all the rows here with their respective months as headers. We can see that for January we get 30 as the output, which is nothing but 12 plus 12 plus 3 plus 2 plus 1. Similarly, we can total it for all the other months. We can also use col sums to get the totals for all the zones, that is, the columns. As mentioned, we can also find the mean of rows and columns. For that, we use the functions row means and col means. We get the average region-wise and month-wise for both. What if we want the sum for a particular row or column? Say we want the sum for the month March only. For that, we write sum and square brackets b, 3 and then comma, since we want it for all the columns. We see that the output we get is 68, which is nothing but the sum for the month March. Similarly, we can find the sum for zone 3 by putting a blank before the comma to indicate all rows and inputting the digit 3 after the comma to designate column 3 to the formula. We get the sum as 60, which we can check by summing up the values for column 3 for each month. This is how the elements of a matrix are accessed and the functions are used on them. Next up, we look at another data structure, arrays. Arrays are multidimensional matrix. Let us create two vectors, m and n, with these values. Now, we define x is equal to array. There are two arguments in an array. First is the values we have to insert in it, and the second is the dimension of the array. For data, we write n and m both. Then, after the comma, we mention dim is equal to 3, 3 and 4. This means that R will generate 4 matrices of 3 by 3 dimensions each. As we press enter, we get an error. This is because we forgot to put the brackets in the beginning and at the end, and also that n and m should be written in the form of a vector. Now when we execute x, we get 4 matrices of 3 by 3 dimension. We can see the elements are entered column-wise. First, the elements of n are entered and then m. The same thing is done for all the 4 matrices. Thus, arrays can store multi-dimensional data in various matrices. It is very important to understand the data structures properly, as these will help us conduct analysis in the later videos. This is it for now. Thank you.